Hello everyone. Today we are back with one of the most used algorithm in supervised machine learning, which is the XGBoost algorithm. The flow for this video will be: first we will understand what do you mean by XGBoost, then how does the algorithm perform, then we will finally build a model from scratch and understand the hyperparameters in detail. So before we start, here are a few details about DataMonk. In DataMonk, we help students to perform different type of interview and provide study material for their references. If you want to know more about the DataMonk, then you can visit our website www.thedatamonk.com. So first of all, what do you mean by XGBoost? XGBoost is a decision tree based on a simple machine learning algorithm that uses a gradient boosting framework in prediction problems involving unstructured data like image, text, and etc. Artificial neural networks tend to outperform all other algorithms or frameworks. However, when it comes to a small to medium structured tabular data, decision tree based algorithms are considered best in class right now. So, XGBoost stands for Extreme Gradient Boosting. The name XGBoost, though, usually refer to the engineering goals to push the limit of the computation resources for boosted tree algorithm, which is the main reason why many people uses XGBoost. In many hackathons, XGBoost is one of the favorite algorithm for the winners, and many people have achieved first rank while creating a XGBoost model. So let us understand with the image. So here is how XGBoost developed. As you can see, XGBoost, gradient boosting, random forest all developed from the decision tree. Like decision tree is parent for all this algorithm. So as you can see from decision tree, first developed a random forest which uses the bagging algorithm. Then after that, it developed a ADA boosting algorithm which uses the boosting algorithm. But after the ADA boost, there come XGBoost, which is the more powerful version of the ADA boost, like optimized gradient boosting algorithm through parallel processing, tree pruning, handling missing value, and regularization to avoid overfitting or bias. The reason for the popularity of XGBoost is like it can handle the large dataset with ease. The training speed of the XGBoost is very fast, and it generally gives the highest accuracy among all the algorithm for most of the dataset. So now we will see how XGBoost is differentiated from the normal boosting. The unique thing about XGBoost is how exactly it corrects the mistake of the previous model. In our previous video, we have discussed about the ADA boost, and in that video we discussed how it gives higher weight to the incorrectly predicted rows, and the next model focused to reduce that. But in XGBoost, the approach is focused on reducing the error gradient, which is the mistake of the previous model. So as you can see in this figure, this is our iteration 1, which means that this is our original data set where y is our original target. So we have created a model 1, then uses the prediction for predicting the price of the y. So here is the prediction of our model 1. Then after that, we will introduce a new target variable which is e1, which will be our y minus y1. So as you can see here, 2500 minus 2300, which will give us 200. So it is the error gradient of y and y1. So from this, we get the updated target as e1 in iteration 2. Then similarly, we will create a model and use the prediction for the prediction. And here we get our prediction as y2. So we will again predict our e2, which will be e1 minus y2. So as you can see, 200 minus 150 will give us 50. 100 minus 90 will give us 10, and 50 minus 60 will give us minus 10. So we will continue this process till the number of iteration assigned to our model, and then for the final prediction we will calculate the mean of all y1, y2, y3, means all our prediction for our final prediction. Hence we will get our final prediction, which is more accurate than ADA boost, random forest, and all other algorithms, because we have used bagging as well as boosting in the XGBoost. So here is some information how our XGBoost algorithm work, so you can read it. XGBoost is also known as an additive model, since you keep adding weak learner model on top of the first one, and in the end you get a strong predictive model. So now you are familiar with what do you mean by XGBoost and how does XGBoost work. So let's build a model from scratch with some EDAs and discuss XGBoost hyperparameter in detail. One more important thing for XGBoost is XGBoost can work for regression as well as classification. So first we'll see how the regression of XGBoost work. Then after that we will see how the classification of XGBoost works. So for regression case study, our problem statement is that we have to predict the price of computers based on its feature. Our target variable is price and predictor variable is speed, HD, RAM, screen, and etc. So first we will explore our data. So to explore our data, we have to import two libraries, Panda and Numpy. Then we have read the data using read CSV function. So here's our address of our file. Then after reading the data into data, we have print the shape of our data. Then we have used drop duplicate to remove any duplicate rows, if any. Then after using drop duplicate, we have again printed the shape of our data to see how many rows have been deleted. So as you can see, it was our shape before the deletion of duplicate values, which is 6259, and after deleting the duplicate values, there is 6183 rows, means that we have deleted at most 80 rows in this data. Then after that we have printed the data head, and now you can see our data, how it look like. This is our target variable and this all are our predictor. Now in this we will see which are qualitative, quantitative, and categorical, and then after that we will see visualization of each predictor. So after seeing the head of the data, we have used the data.info function, which help us to summarize the information of the data. By using this, we can see the nominal values, like we have total number of data entry, which are 6183. And we can see if any row have any missing column, but in this all have 6183 values, means that there is no missing value among every column. But if the missing value is greater than 30% of the total number of entries, then we can automatically remove that column from our dataset. Then after using the info function, we have used the describe function to see the statistical distribution of our data. By using the describe function, we can see the mean, 25%, 50%, and 70% of our data. And by using this function, we can also distinguish between the categorical and numerical values. Then after the describe function, we have used the nUnique function to see the differentiation between the categorical and continuous variables. So as you can see, if our unique value is less than 20, then it will be our categorical value. And if it is greater than 20, then it will be our continuous value. So in this, our continuous variable will be price, HD, ads, and trend. And our categorical value will be speed, RAM, screen, CD, multi, and premium. So after distinguishing between categorical and continuous variable, we will see the visualization between the categorical and continuous variables. So first we will visualize the categorical predictor variable in the data using the bar plots. So we have written a function for plotting the categorical predictor value. So here is our function, and we have plotted the box plot for speed, RAM, screen, CD, multi, and premium. So here is our bar plot for categorical predictor variables. And in this, as you can see, in CD we have two unique value, no and yes. In multi we have also two unique value, but in RAM we have 6 unique value, and in speed we again have 6 unique value. So in this we can also see the distribution and how many unique values there are in the particular column. Then after plotting the categorical variable, we will plot the numeric variable using the histogram. So for numeric variable, we do not have to write a function, as we are not grouping the data. So we can simply use the data.hist and write the name of our columns, then use the fixed size to set the size of the graph. So in this, our column will be price, HD, ads, and trend, where price is our target variable and HD, ads, and trend are our predictor variables. So for price, we can see that we have a desirable bell curve, so we can predict the price of the computers. And in this, we can also see that for HD, we have somewhat of positive skewed bell curve, and in ads and trend, we have a good bell curve, as we can see the distribution. So after the single visual distribution of a particular column, we will see the relationship between the variable using the visualization. So for continuous versus continuous, we plot scatter plot. For continuous versus categorical, we plot bar plot and box plot. And for categorical versus categorical, we only have a one option, which is bar plot. So first we will see the relationship between the continuous versus continuous. So we have plotted the scatter plot against price versus ads, HD, and trend. So we have plotted three scatter plot, and you can see the scatter plot for price versus ads, price versus HD, and price versus trend, where target variable is our y-axis and predictor variable is our x-axis. Then after seeing the relationship using the visualization, we will see the relationship between the continuous versus continuous using the statistical measurement. So for continuous versus continuous, we use correlation matrix. And in correlation matrix, if our value is greater than 0.4 or 0.5 or less than minus 0.4 or 0.5, we can consider that it have a high relationship between the target variable and the predictor variable. So we have plotted the correlation matrix using the data.core function, and you can see our correlation matrix. In this correlation matrix, our this column is only important as this is our target variable. So we can see that like price versus speed, our number is 0.29, which means that it is a positive relationship, but price and speed are not so much correlated with each other. But in price versus HD, it shows that it have a positive relationship and a good dependency between each other. So we have written a statement to filter only those columns where absolute correlation is greater than 0.4 with price. So as you can see, only HD and RAM have a high relationship with the price. So we can neglect our ads and trends which show very low dependency with the price. So after seeing the relationship between the continuous versus continuous variable, we will see the relationship between the continuous versus categorical variable. So to visualize the relationship between continuous versus categorical variable, we use bar plot or box plot. So to use any graph, first we have to group the data of the categorical variable. So we have grouped the data of categorical variable, which is speed, and as you can see, this is our group data in respect of the mean of the speed. So it means that if our speed of a computer is 25, then our average price of the computer will be around 1800, and our HD will be around 244, and our RAM will be around 6 GB, and so on. Then after the group data, we have plotted the bar plot, and it tells that our average price for each speed. So as you can see, as our speed increases of the computer, our price will also increase with respect to the speed. So after seeing the visualization relationship, we will use the statistical function, which is ANOVA test for continuous versus categorical variable. So for ANOVA test, we use the hypothesis testing. In this, we take assumption as our H node, which tell that there is no relationship between the given variable. So if our H node is greater than 0.05, it means that there is more than 5% chance that there is no relationship. So we will take the value of P if it is less than 0.05. So we have written the function for performing the ANOVA test, and our categorical predictor are our speed, RAM, screen, CD, multi, and premium. And our target variable is price. So we have plotted the p values for each categorical predictor. So as you can see, our speed, RAM, screen, CD, and our premium are highly correlated with our price, but in multi we have got the p-value as 0.19, which show that there is 20% chance that there is no relationship between the given variable. So we will not consider multi in our predictor variable while building the model. So after the feature selection of categorical and continuous variable, we will pre-process our data. So for pre-processing our data, our first step will be to treat the missing values. So first we will see how many missing value are there in a particular column. So as you can see, we have zero null value for every column. So we do not have to treat our missing column. But if there is some value in like screen equal to 10, so we have to treat our screen data using the interpolation method. And for interpolation method, we have different function for continuous and categorical variable. For continuous, we have like linear, quadratic, and for continuous, we have like FL, bfill, and all that functions. So after treating the missing value, we have to convert our categorical data to our numeric data. As in our model, we cannot take like yes, no values. So we have to convert it first. So first we have printed our data column for our reference and see how many columns we have to delete, as they show very less relationship with the price. So we have deleted our useless column, which are multi, ads, and trend, and now this is how our data look like. After that, we have to treat our CD and premium as they have no and yes as values. So how we treat that? We simply replace yes by 1 and no by 0. So we have written the statement for CD and premium and replace yes by 1 and no by 0. And now this is how our data look like. And you can see the difference between previous dataset and new dataset where we have replaced no by 0 and yes by 1. So now in new dataset, we can see that our values are all in numeric function. So we do not have to treat the nominal variable using the dummy function. So now our data is ready for splitting into testing and training dataset. So in every machine learning algorithm, splitting of data into training and testing sample is very important. So for testing data, some data is randomly selected and kept aside for checking how good the model is. This is known as our testing data. And the remaining data which is used to build the model is known as our training data. Typically in industries, we use 70% of our data as training data and the rest 30% as our testing data. So for first statement, we have written data dot column for our reference. Then we have assigned the value of target variable and predictor, where our target variable is price and predictor are all column which are left after the ED selection. Then we have imported the library train test split for splitting our data into xtrain, xtest, ytrain and ytest. And we have splitted our data in the ratio of 75% as our training data and 25% as our testing data. And for random set, it is just a number which tell us that this is the order in which we have picked our data from whole data set. Then after splitting the data into 4 parts, we'll see the shape of all the 4 parts. So as you can see, for xtrain.shape, we have 4637 rows and 6 columns. For ytrain shape, we have 4637 rows and only 1 column. And same for Xtest data and Ytest data, we have 1546 rows. So now our data is plated and ready for the XGBoost. So we will fit our data in the XGBoost and predict the values and see our accuracy. So first of all, for XGBoost, we have to install XGBoost using the pip install XGBoost, because in Python or Anaconda, XGBoost is not a default file, so we have to install it manually. So after installing the file XGBoost, we will import our XGB regressor for XGBoost. We have used XGB regressor because we are doing the regression model. Then for hyperparameter of XGBoost, we have 5 different type of hyperparameter. So as you can see, our first 3 parameter is same as our random forest and decision tree, which are max depth, learning rate, and an estimator. So for max depth, it is just the height of the tree, like what height we have to choose. And for learning rate, in simple term, it is just the measure of how much weight we have to assign to the incorrect values. And for an estimator, it tells us that we will build this number of tree and see the average accuracy of the n estimator trees. So for an estimator equal to 500, it tells us that we will build 500 trees and see the accuracy of 500 trees. So after these 3 common parameters, we will see what is objective and booster. So in objective, for regression, we always use reg.linear, which tell us that we are doing the regression model. And if we have to build the classification model, we will use binary.logistic. And for booster, booster can be of many types, but the best booster in today time is GB tree, which means that gradient boosting tree. You can also have linear booster in many types, but GB tree give us the best accuracy. So basically for regression in XGBoost, we just have to tune these 3 hyperparameters, max depth, learning rate, and an estimator as our objective, and booster will be always fixed. So after tuning this hyperparameter, we can get our best accuracy. Until now, you have already seen that our this statement is same in all our models, so you don't have to worry how can you remember this many number of code. So after tuning the hyperparameter, we will fit our data into our reg model using xtrain and ytrain, and then predict using xtest and assign it to our prediction. So till now our model has been created, and now we will only see our measurement, which are R2 value and the accuracy value. So as for R2 value, it will always be between 0.5 to 0.9. So you don't have to worry for that, because in decision tree we cannot see the goodness of it of our training data. But for accuracy it can go up to 90% or 100% as per your hyperparameter. So after measuring the R2 value and accuracy, you can also see our R2 value, which is 0.75, and our accuracy, which is 89.32%. Then we have plotted our feature importance chart, which is very important in every decision tree type of algorithm. So here's our feature importance chart. So as you can see, our RAM carry highest importance, means that it has the highest bifurcating power, which can divide our dataset into two parts. And we can consider all our predictor as important, because in feature importance chart they all have some values. Then after seeing the feature importance chart and the accuracy of our model, we will plot our decision tree out of the XGBoost. So you should know that XGBoost is not yet implemented under GraphWiz. Hence, we can use its own method to plot it. So we have used plot tree from XGBoost. Then after that, we have important plot from the pyplot in matplotlib and use the subplot to plot a particular tree. So from this line, we can see that we have plotted the XGBoost tree wherever XGBoost tree number is 200, and this is our XGBoost tree. So in this tree you can see that it differs from AdaBoost and random forest tree. In this tree, what do you mean by F1 or F2 or leaf? So for F1 it is just the feature number 1. And how we divide the feature? So as you can see, for our speed it is our feature 0, for HD it is our feature 1, for RAM, it is our feature 2, and for screen, it is our feature 3. So now you understand what do you mean by F1, F2. So for leaf, if it is a regression model, then the leaf value is the prediction of that tree for the given data point. The leaf value can be negative, as you can see in this and this node, based on our target variable. The final prediction for that data point will be the sum of all the leaf value in all the trees for that point. So as you can see, this is our only one tree out of 500 trees. So like if we have to find the value of this leaf, so we have to calculate the sum of all the 500 trees of this particular leaf. So now you understand how to write the XGBoost regression model and plot our decision tree for XGBoost regressor. So now we will see our XGBoost classifier. So for XGBoost classifier, we need our different data set. So we have imported our Titanic survival dataset from our local computer and delete our all duplicate value in our dataset. So here is our dataset for Titanic survival dataset, and we have to predict the survival column. Then in this dataset, we have to remove all the missing value in our dataset. So we have used the drop now for removing all the missing values. So after dropping all the qualitative column, we have to treat the missing value. So for treating the missing value, we can choose two options. First is to drop the missing value, and second is to treat the missing value. So for this we have dropped the missing values. After dropping the missing value, we have to treat the nominal variable. So to treat the nominal variable, we have assigned male equal to 1 and female equal to 0 in our dataset. And now you can look in our sex, which is 10001, which means 1 equal to male and 0 equal to female. Then after treating the nominal variable, then we can treat all the nominal variable using the dummy variable. So we have got a function known as getDummies. We have applied it in our data set. So as you can see, we have embarked column which have value like SC, SSS. So we have used dummy variable to treat this. Now it look like this, as you can see. Like in the first column, we have embarked equal to S. So it will be like 001. And in second we have embarked equal to C, so it will be like 100, and so on. Then after treating the data, we have split the data into training and testing data in the ratio of 75% and 25%. So after splitting the data into training and testing sample, we will fit our data into our model of XGBoost classification. So for XGBoost classification, we have 5 hyperparameter. So as you have already seen in our regression, so for regression and classification, our hyperparameter will be same, which are max depth, learning rate, n estimator, objective, and booster. And in this, our only change is in our objective, which is binary logistic. It tells us that we are doing the classification model. And if it is linear regression, that means that we are doing the regression model. And you already know that our booster GB tree is the best for the booster. So we will fix our booster as GB tree. So again, we only have to tune our three hyperparameter, which are max up, learning rate, and an estimator with respect to our accuracy. So after tuning our hyperparameter, we will fit our data and then predict our prediction using the X-test. And you already know that for measuring the accuracy in our classification model, we use classification report and confusion matrix. So we have printed our classification report and confusion matrix, and you can see here, this is our confusion matrix and this is our classification report. So we have printed our F1 score as our accuracy, which is 80%. And after that, you can see this column is same in regression and classification. So first we have printed our feature importance chart for our 10 most important column. So here's our feature importance chart. As you can see, our sex carry the highest importance. Then after sex we have p class, then sub sp, then other predictor variable. So this means that our sex has the highest bifurcating power, which can divide our dataset into two parts. So after creating the XGBoost classification model, we will plot the single decision tree out of all the 500 tree used in the XGBoost. So first we have imported plot tree from XGBoost. Then after the import, we have plotted the 10th number of the tree out of the 500 trees, and other code is same as for the regression model. So is the 10th decision tree out of the 500 trees in our XGBoost, and as you can see, it is same as our regression decision tree, but the height of our tree in this is 3. And for F1 and F0, it is just the number of the feature, like F0 equal to P class, F1 equal to sex, F2 equal to age, and F3 equal to sub sp. So as our sex has highest importance, which is our F1, so it will be our root node. So as you can see, it is our root node. Then after that we have P class, which is our F0 as our second parent node. And for leaf node, we have already seen the function of the leaf node. So we just have to calculate the sum of all the 503 for getting our particular prediction. So that's all for XGBoost. So in this video, we have seen what do you mean by XGBoost and the code for XGBoost regression and the XGBoost classification. So that's it. Thank you for your time. Hope you like the video. For more amazing content, do like and share the video.